Hello everyone, welcome to George Mathworks. Now my lesson today is on analytical geometry, and I'll try by all means to put the terminology as it should be. In this, remember I always put an emphasis on the language. Now with today's lesson, at the end of it, one is supposed to be able to do the following: calculate the midpoints, find gradients, calculate distance between points, equations of straight lines, and many other things. And I will also display the exam type questions that can be asked. With that said, let's look at the theory behind analytical geometry. Now, with analytical geometry, my starting point is this, which we refer to as a point in maths. Whenever you hear a point being mentioned, you are supposed to find the x and the y value, the coordinates. That's what marks a point in maths. Each time you hear a point, be it in functions and graphs, be it in any other topic, even analytical geometry itself, when the word point comes up, it means coordinates. We are supposed to know that. Then if you have 2 points in mathematics and you join them, you form a straight line. Now if you have a straight line, as shown here, you can be asked to calculate the midpoint between those 2 points you're given. And there is a formula for calculating the midpoint. A midpoint, since the word point is still existing in this term here, it means our final answer should be in coordinate form. That means the x value and the y value. So to calculate the midpoint, you're going to say x1 plus x2 all over 2, semicolon, y1 plus y2 over 2. All this will be clear with the examples that are coming up. Now as well, if you have 2 points in mathematics, you can be asked to calculate the distance between those points. And when you hear the word distance, in some instances they use the word length. If you are displayed with such, then the distance is given by the square root of x2 minus x1. These, remember, are coordinates. You'll be having 2 points, where one is the x value at one point and the other one the x value at the other point. So x2 minus x1, everything is squared, plus y2 minus y1, everything is squared. With this said, if you are asked to calculate the length, this is the formula you have to write down first. Now, I mentioned that if you have 2 points and you join them, you form a straight line. Now, a straight line has a general equation. Y is equals to mx plus c, where m represents the gradient. The gradient is calculated by the change in y over the change in x. That means y2 minus y1 over x2 minus x1. That's how you calculate gradient. At the same time, this which we refer to as gradient tells us more stories. Number one, if the gradient is positive, it means your line will be ascending. If you see a positive gradient, it means your line will be going up. At this point, I'm trying to give you a hint. Something you will use whenever you are asked questions in the exam as a reference to check whether your answer is meaningful. If you find a positive gradient, it means the line that you are to sketch, or the line that was already sketched, should be ascending. Now, if the gradient is negative, the line should be descending, which means also that if the line is descending, the gradient should be negative. We will see with the types of questions that are asked how this can help us. Now, at the same point, this which we call gradient also tells us more about lines. Parallel lines, 2 lines AB and CD are said to be parallel if and only if their gradients are equal. So if the gradient of the line AB is the same as the gradient of the line CD, then those 2 lines are parallel. Now, lines can be perpendicular as well. 2 lines AB and CD are said to be perpendicular if and only if the product of their gradient is -1. Now, we shall see questions that require much this knowledge that I just explained here. Now, we also have to cover something about this. Here with me, there is a right angle triangle indicated by this 90-degree angle here. And I drew this in a Cartesian plane. Now, when you see a right angle triangle, those who have covered trigonometry, if not, we shall do all those things. Now, if you have a right angle triangle, there are 2 things that should come into your head. That is the Pythagoras theorem and some would say SOHCAHTOA, some would say CHAOTAO. the relationship between the angles and the sides of a right angle triangle. Now I'm going to use this to explain something splendid that we are going to be using in this tutorial, in this lesson. Now, if you see a right angle triangle, we just calculated gradient. We said gradient is the change in y over the change in x. Suppose you're asked to calculate the gradient from this point to this point here. So if you are asked that gradient, it will be y minus 0, because remember it says y2 minus y1. So it's y minus 0 over x minus 0. In the end, you are getting x over y. Now, to those who covered soccer tour, you agree with me that from soccer tour, there is a relationship between opposite, adjacent, and tan. Tan theta is equals to the opposite over the adjacent. The side referred to as the opposite is the one that is opposite the given angle. So here, tan theta is equals to y over x. Again, tan theta is opposite over adjacent, which is y over x. At this point, you see that, okay, gradient is equals to y over x. Tan theta is also equals to y over x. Now, this simply means that the gradient is equals to tan theta. So there is a relationship between tan theta and our gradient. We shall use this quite a lot. So there's one thing that I haven't explained. C from the y is equals to mx plus c. C represents the y-intercept, the point where x is equals to 0. That's the point where the line will cut the y-axis. Those are some of the things we have to understand. Now, with this one said, I mentioned gradient here. So I'm going to take you to a few examples that show how questions can be asked on gradient. And with that done, we also get to look at the examples in the exam. Finding the gradient, first thing to do is to display the formula. That's y2 minus y1 over x2 minus x1. So with me here, there is an example. It says, find the gradient of a line passing through the points 2, 6 and 4, 12. Now, at this point, the first thing to do is to write down the formula as indicated here. You write down the formula. Now, it is your choice to choose which one to mark x2 and which one to mark x1. So I can choose to say, okay, this one here be my x2 and this one be my y2. And right here, I have my x1 and here my y1. So the change in y over the change in x now becomes that. It becomes 12 minus 6, should be 6 here, over 4 minus 12, 4 minus 2. This 4 here, subtracting this 2 there. So in the end, you are getting your gradient to be 6 over 2, and your final answer is 3. So if the final answer now is 3, our gradient is positive in this case. And positive gradient imply that the line will be ascending if we are to sketch a line like this. That's something we covered. Now, I have been mentioning this. How do we even find the equation of a straight line if it is asked? Now, the equation of a straight line, each time you hear a question specifying the equation of a line, the first thing to do is to jot down y is equals to mx plus c. That's something to do. Now, there are 3 cases that I'm going to explain here. Number 1, you are provided with the gradient and the intercept and you are asked to find the equation of a line. Now, how do we do that? Find the equation of a line whose gradient is 4 and whose y-intercept is 5. Now, with this one done here, we need to make sure that we write down first y is equals to mx plus c. Y is equals to mx plus c as we said. Then gradient is given in this sentence as 4 and the y-intercept is given as 5. So here, where there is gradient m, I put 4. Where there is intercept, I put 5. It's given from this question. Now, so this has given me the equation of a line y is equals to 4x plus 5. Now, case number 2 that we're going to discuss here, you are given a gradient and a certain point. Find the equation of a line whose gradient is 4 and passes through the point 2, 6. Now, the first thing to do again is to write the equation. Y is equals to mx plus c, where m represents the gradient, of which the gradient is given in the sentence. Gradient is 4. What we don't have is C. Yes, we do have a certain point where the line is passing through. Now with that, you have to substitute where there is M. Remember, finding the equation of a line simply means find the gradient and find the y-intercept. Find the gradient, find the y-intercept. So here, y is equals to 4x plus c. That's what I have. Now, the line is passing through this point 2, 6. It means that this point satisfies the line. What do I mean by that? These are coordinates. This one is the x value. This 6 is the y value. With that one, where there is y, I put 6, and where there is x, I put 2. This should be true. If the point lies on the line, it satisfies the line. Now, from this, you are now doing algebra to make c the subject of formula. 6 is equals to 8 plus c. So 6 minus 8 is equals to c, which means that your c is equals to minus 2. In the end, y is equals to 4x minus 2. That's case number 2. Then case number 3, you are just given 2 points and be asked to find the equation of a line. Find the equation of a line that passes through the points 2, 6 and 4, 12. Now, if you have 2 points, remember you can calculate gradient. The job here in finding the equation of a line is to find the M and C. So, at this point, my gradient is given by 12 minus 6 over 4 minus 2. 12 minus 6 over 4 minus 2. Remember, it's changing y over changing x. And my gradient is 3. Now, what is left is, I now have the gradient, which means I can write this as y is equals to 3x plus c. What I'm left to find is c. Now, at this point, we are now more like doing the case number 2, where you have the gradient and the point. There are 2 points given, but it is mentioned that the line passes through both, which means both of them can help you get c, and it will be the same answer. So here, again, I used 2, 6. Where there is y, I put 6. Where there is x, I put 2. In the end, I got my c to be 0. Therefore, my y is equals to 3x. That's the equation of a line. Now, at this point, I'm going to take you to the exam type questions, where we need to pay attention to the language and apply those pieces we just learned. So, without wasting time, let's see the example. Now, what we are looking at is an exam type question on analytical geometry. I'll read the sentence, which we should all do. In fig 1 below, P has coordinates minus 3, 5, Q has coordinates 1 and minus 1, and R has coordinates 4, 1, are the vertices of a triangle PQR in a Cartesian plane. Determine the following. So the description above is also given in the diagram here. The diagram represents that description there, where we have P, we have Q, and we have R. Now, the questions that follow are, number 1, we are to determine the length of, of QR. Leave your answer in said form. This part is also important. Now, the length of QR. So here, we are going to do the following. I'm going to write down the coordinates of Q. I'm going to write down the coordinates of Q and the coordinates of R clearly here. So we want to answer the question number 1. We want to do question number 1 here. So the coordinates of Q are 1, minus 1, and the coordinates of R are minus 3 and 5. What we are asked to find is the length QR. And from our notes, we learned that QR length is given by square root of x2 minus x1 squared. X2 minus x1 squared, then plus y2 minus y1, then squared. This is the formula in general that we covered. So here, it will be the square root of, I can say this is my x1, my x2. So I will have minus 3 minus 1, everything squared, plus 5 minus 1, everything squared there, and everything under the root. So here, it will be the square root of minus 4 squared plus the square root of 5 minus minus 1, that ends up becoming 5 plus 1, which is 6, then squared. So here it becomes the square root of 16 plus 36. Square root of 16 plus 36, which then reduces to the square root of 52. Now remember, our question specified to say leaving your answer in set form. Now if you punch this in a calculator, you are going to get your answer to be 2 root 13. Let me change that size of a pen there. That's not a good one. Right. So this is your answer in set form. Now let's look at the question that follows. The second question says the gradient of PR. The gradient of PR. Now we just learned how to calculate the gradient. This is question number 2. When you hear gradient, you're supposed to first write down the formula ym is equals to y2 minus y1 over x2 minus x1. Now with that done, we want the gradient of PR. P is the coordinates minus 3, 5, and R is the coordinates 4, 1. Now if we look at this line is descending. This is our guide to say whatever I do, my answer has to be negative. Remember, if the gradient is negative, the line is descending. If the line is descending, the gradient should be negative. That's what we covered in the earlier parts of this lesson. Now, if I want this gradient, I am going to say, okay, change in y over change in x. So my p coordinates are minus 3 and 5, and my r coordinates are 4, 1. So I can say this is x1, y1, x2, y2. Now with this one done like that, so I am going to perform now substitution here. It's formula first, then substitution follows. Now I'm going to say 1 minus 5 over 4 minus 3, following the formula above. So this gives me minus 4 over 4 minus 3, that's end up becoming 4 plus 3, which is 7. So at this point, my gradient is negative 4 over 7. My gradient is negative, my line is descending. I should be happy because it makes sense like that. Then the next question that follows says that the coordinates of the midpoint PQ. Now, we are asked the midpoint PQ. So I'm going to write down the coordinates first. The coordinates of P, we've used them, it's minus 3 and 5. And the coordinates of Q are 1 minus 1. Let me double check that. Yeah, Q it's 1 minus 1. So midpoint, the midpoint from the notes we said midpoint is given by x2 plus x1 all over 2, then y2 plus y1 all over 2. So in this case, I'm going to have minus 3 plus 1 all over 2, then 5 minus 1. Since it's positive in the formula, a positive and a negative here, I'll end up having a negative. Then all over 2 like that. Remember, it's a point, so my final answer should be in coordinate form. Minus 3 plus 1, that gives me minus 2 over 2 here. Then 5 minus 1, that's 4 over 2 here. So my midpoint in the end becomes now minus 1 and 2, if you simplify that. So this is the point where this is the x value and this one is the y value. That's it on this question. Then we move to the next one. The next question here says the equation of a line, the equation of the line parallel to PR passing through the point Q, leave your answer in general form. Now, parallel to PR. So parallel to PR, there's something we discussed here. The question number 4 it wants us to find the equation of a line. Question number 4. It wants us to find the equation of a line, of which the minute I hear that, I think of y is equals to mx plus c. I need to find the gradient and I need to find the intercept. But there are important words that are used here. The equation of a line, this part, we already wrote it down, of the line parallel to PR. Now the question is, when do we say two lines are parallel? We said two lines are parallel if and only if their gradients are equal. So if the line that whose equation I want to calculate is parallel to PR, it simply means that the gradient of PR will be the same as that gradient. We got the gradient of PR to be minus 4 over 7. Therefore, the line that I want to calculate, it will have also the same gradient. Y is minus 4 over 7, x then plus c. Since they are parallel, it means equal gradients. That's what we covered. Two lines are said to be parallel if their gradients are equal. Now, at this point, the sentence continues to say, and passes through the point Q. So the coordinates of Q, we know them here as 1 minus 1. So at Q, my coordinates are minus 1. Sorry about that. Let me remove that. The coordinates are 1 minus 1 like this. Therefore, if the line is passing through this point Q, at Q, it means that this point will satisfy the equation. So I have minus 1 is equals to minus 4 over 7. Minus 4 over 7. Where there's x, I put 1, then plus c. So minus 1 is equals to minus 4 over 7 plus c. It's minus 1, then plus 4 over 7, then plus c. Sorry about this one again. It's not plus c, is equals to c, like that. So if you simplify that, you will get minus 3 over 7 is equals to c. Now with this one done, we have everything we need to conclude the line. Therefore, the line is now y is equals to minus 4 over 7x, then minus 3 over 7. This is the equation of the line we were talking about. That's the equation of the line that we wanted. So it's done. So thank you for this one. I'm not going to do the other one. We'll continue in the other tutorials to answer more of these exam type questions. Please contact me if you have many questions or many other things you would like to know. But in this video, please pay attention to the terminology. We have seen that the questions themselves, they bring us a word or words that will guide us to take a step towards the right direction in answering the question. So thank you so much for listening, for watching this one.